Hello, fifth graders, and welcome to your math lesson for today. For today, you will need your 5B textbook, your 5B workbook, and paper and a pencil. If you need to pause and go get those things, you may do so now, and then come on back. All right, fifth graders, so as you've been hearing me say again and again and again and again, we are going to be doing practice problems. These are going to be kind of continuing to cycle through review and will be kind of prepping you for upcoming quarterly exam. So this is very much the type of problem that you would see on an exam. So we're being told there's kind of like a couple things happening here, right? We're being told to arrange in increasing order. So you kind of have to think if things are increasing, they're getting bigger, okay? So increasing order, if it's getting bigger, that means you have to start with the smallest and go to the biggest, okay? We actually kind of talked about this on an earlier one as well, so we should be somewhat familiar with this. Now, remember, we're seeing both fractions and decimals here. And we've learned how to express fractions as decimals and vice versa. We've already practiced that. That's been part of this unit. So as we're comparing these, we're going to want to make some conversions one way or the other. So personally, I always find it best for me to express them into decimals because with decimals, everything in decimals has the same denominator, so to speak. I'm saying denominator in quotes, right? Because we're talking about tenths or hundredths or thousandths. So everything as the decimals already has the same denominator. Whereas if we turned our decimals into fractions, that gets trickier because now we have to start looking at common denominators. So there might be an extra step there. So my recommendation is always to be going from fractions to decimals. However, I mentioned this earlier, when you get to your final answer, you want to express it in the way that it was given at the beginning. So even when you're making your conversions, your final answer should have them as they're written here, okay? So we've tried this, I think, together before, but go ahead and pause, give it a try, come on back and see how you did. So following my guidance, right, I said to express this as a decimal. So 3.5, right, we can do that pretty quickly. Also, when we see a whole number like 3 in comparison, that usually we could probably do it without converting it because you just could be able to look at the 3 and how it looks in comparison. Okay, so 9/5, if you were going to express that as a decimal, we'd want to do our division, right? So 5 goes into 9 once, remainder of 4, we bring down a 0, and then 8. Okay, so 9/5 is the same as 1 and 8/10. Okay, 3 divided by 8, we do that division as well. We're actually going to have to go out 3 places, you probably saw. So 8 does not go into 3. It goes into 30 3 times with a remainder of 6. It goes into 60 7 times, remember, 5, 6, 7, 8. And it goes into 40 5 times. So now we know that this is equal to 375 thousandths, okay? So now we should be able to put it in increasing order. So I would focus on our whole numbers first. Our smallest whole number in this case is 0. So we have 2 that are equal to 0. So 0.3 something, 0.4. So which one's smaller? Our 0.3. But remember, we don't want to write 0.3. We want to write our fraction. So we start with 3. You can't see that. 8ths. There you go. Okay. So now we've done that one. I would cross it out. Then you know for sure. Our next one we have is 0.4, or we would say most properly 4/10. Our next whole number is going to be 1. So we have 2 with 1. So 1.8, 1.4. So 1 and 4/10 will be next. Then we have 9/5. And then finally 3.5. How'd you do? This is definitely something you're going to see on upcoming tests and homework assignments. So again, if you're feeling stuck on this, come see me. I want to help you. I want to talk to you about it. Okay? Okay. With that, we've been doing all kinds of multiplying and dividing of decimals. Okay? Specifically looking at kind of like tenths and hundredths and thousands and multiples of that, or multiplying decimals by a whole number. So today we're shifting gears and we're going to be working on multiplying a decimal by a decimal, okay? And we're going to be using estimating in order to help us out, but there's also a rule that you can apply anytime you're multiplying a decimal by any other number, and it'll apply every time. And I'm going to tell you a secret. You actually know this rule because I've said it a bunch of times, okay? Kind of. I've hinted at it. I should say I've alluded at it a bunch of times. So hopefully when you hear it, you're going to say, ah, yes, that's familiar. So in our textbooks, we are going to be looking at page 37. So you can go ahead and open your textbook to page 37. I'm going to flip you around so that we can work together. So we're going to start off on number 7. And again, we'll be looking at this estimating and then multiplying in order to see how we're getting to this answer. And then we're going to start working on applying that rule of ours. Okay, so we're going to be multiplying 4 and 23/100 by 9/100. Okay, so we start with our estimate, which remember, we really want to make this as simple as possible. So in this case, this is like we've already done before. This is what we just had a lesson in on Friday, I guess. So remember, we're going to round this number to our whole number of 4, and then we keep our hundredths place the same. And then we can break it apart into, remember, we want to basically just be able to be multiplying our whole numbers. So we've broken this apart into 9 and 100. So 4 times 9 is 36. And then we're multiplying by 100th, so we go 1, 2 to the left per our rule that we learned last week. So our estimate is going to be 36/100. Okay, so now we want to go and set up our vertical algorithm. And you'll notice these actually do happen to line up, but when we're multiplying decimals, I said this earlier, and that still is true. We don't have to line up our decimal points when we're multiplying decimals. I'm going to repeat that because it's important to know. We do not have to line up our decimal points when we're multiplying decimals for multiplication, okay? In this case, they happen to, but that's because it just happens to be the case. You don't have to do that. So now we do our multiplication as usual. So 9 times 3 is 27, and we regroup that 2. 9 times 2 is 18, plus 2 is 20, and we regroup that 2. 9 times 4 is 36, plus 2 is 38. Okay, so now is where we're going to sort of look at our estimate, but also consider this rule. So per our estimate here says 36/100, 0.36. So when we consider where we're going to put our decimal point, here, 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 putting it here actually is going to be our closest estimate, right? 0.3807 is closest to 0.36, okay? So our estimate helps us out to figure out where to put our decimal point in. But we also have a rule that we can apply with our vertical algorithm. Here's our rule, and I've said this before. You want to look at the problem. How many decimal places are in the problem? And that's how many decimal places should be in your product, in your answer, okay? The difference now is that we're going to have decimal places in both of the numbers. Before, when we would talk about this, only one of the numbers would have decimal places, but now we have both of our numbers having decimal places. So let's look. I see 1, 2, 3, 4. Okay, do you see what I'm saying here? We see a decimal point, and then there's 1, 2 places, and another decimal point, and then 3, 4 places. So there are 4 places total that have decimal points. 1, 2, 3, 4 tells us to put our decimal point there. So that's going to be our rule when we're multiplying decimals in any way. We want to see in our problem, how many decimal places are there? That's how many should be in our answer. And our estimate supports that as well, right? We see that our estimate is pretty close. Okay, so let's keep going. Okay, so as we're looking at 8a, again, we're saying estimate, then multiply. So we're multiplying 3/10 by 6/10. So we've done this before, okay? We've looked at this before. And so we kind of are looking at probably, I'd say 3/10 times, I don't even know. I think I'd say times 1 is our closest estimate. If we're trying to use estimates in a way that is simple and straightforward, right? So we're going to end up with 3/10 as our estimate. And again, this is not going to be our closest estimate, but we're trying to make this simple. We don't want to overcomplicate our estimates. So our estimate here is 3/10. So now we're going to do our vertical algorithm. Remember that rule I already told you, and we kind of said this before with multiplying of decimals. You want to put whatever number is longer, meaning whatever number has more digits on top. If they have the same number of digits, then you can do whatever you want in terms of stacking them. But again, our decimal points don't have to line up, and that's going to come into play in B as well. Now we just do our multiplication, right? 6 times 3 is 18. Okay, so now looking at our estimate of 3/10, 18's not a very close estimate. 1 8/10 is a closer estimate, but really 18/100 is going to be our closest estimate. 18/100 is closest to 3/100. And if we think about that rule that we talked about, we look at our problem. I see 1 decimal point place, 2 decimal places. 1, 2. Okay, so our rule supports our estimate. So our exact answer is 18/100. Let's try B. 4 times 7/10. So again, in the interest of keeping our estimate really simple, straightforward, I'm going to say 4 times 1. So our estimate is 4. We're going to have an answer that's about 4. Probably less, but about 4. So now we're going to write our vertical algorithm. I've said this before, just a minute before, that we want to, when we're multiplying decimals, we want to pick the longer number, not the greater number, the longer number. So as we compare this number, our decimal actually has more digits in it. Okay, so we write 7/10 times 4. And then I'm going to repeat that when we're multiplying decimals, we do not have to line up our decimal point. Do you see here that it's not lined up, and that is fine. We don't have to line up that decimal point in multiplication. So now we do our multiplication. 4 times 7 is 28. And so now it comes down to placing that decimal point. 28, not very close to 4. 2 8/10, closer to 4. 28/100 seems like we're getting pretty far from 4. So here is what our estimate would indicate. But remember, our rule supports that, okay? 1 decimal place in our problem, 1 decimal place in our answer. Let's try C. Should have done that higher. My apologies. So again, we're going to be doing our best estimate here. So I would say, like, if I were going to estimate this, I would say 2/100 times 2/10 times 5/10. And really we're saying, like, what's half of 2/10, right? This is a half. So what is half of 2/10? 1/10. So our estimate is going to be 1/10. And again, we're fine doing those decimals because it's something we could do in our heads, right? So as long as we can do it in our heads, it would be, it's an estimate that's going to work. So again, we look at our decimals here. Which one is longer? Which one is longer? So looking at which one is longer, we're going to say 23/100. Yes, it's the smaller, but it's not the longer. And again, remember what I've been repeating. You do not need to line up decimal points for multiplication. Okay, you do not need to do that. So now we can just do our multiplication. So 5 times 3 is 15. We regroup that 1. 5 times 2 is 10. Plus 1 is 11. So now we could look at our estimate, which tells us our decimal point is going to go here, right? 0.1 or 1/10. We want it to be there. But again, we can verify with our rule. We see 1, 2, 3 decimal places in our problem. 1, 2, 3 decimal places in our product. Okay, so we can confirm that our estimate and our exact answer, that works. Okay, so we're going to keep applying that rule. Okay, let's see. I'm going to say that I would love for you to pause and try D on your own. You're going to estimate an answer, find the exact answer. Once you've done that, come on back and see how you did. So remember, for that estimate, we want to keep things, this is actually very close to what we did not yesterday, but Friday, right? So this 3 and 9/10 we're going to turn into 4. And now we can multiply. So we've been talking about wanting to break our decimal here apart in such a way that we're going to be able to do some nice quick multiplication facts with things that we have memorized, right? So now if we do 4 times 7 first, it's 28. And then multiplying by 1/10, we move that decimal point 1 to the left, and we end up with 2 and 8/10. So 2 and 8/10 is a great estimate for this one. Now, neither one of these is longer, so you can put whichever one you want on top. Our decimals do not need to line up, our decimal points. However, in this case, they do, but now we just do our multiplication. So 7 times 9 is 63. We regroup that 6. 7 times 3 is 21. Plus 6 is 27. Making our comparison, we see that our decimal point should go here if our estimate is to be trusted, which it is. We see 1, 2, 1, 2. How'd we do, 5th graders? Again, this is a good touch point for you if things are going well or not. You can kind of pop over and see me. Okay, why don't we go to 8F now? Again, I'd like you to pause. Give it a try. Come on back and see how you did. So starting with our estimate, rounding to 10 to me makes the most sense. So if we're multiplying by 10, this is actually pulling back from our earlier lessons, right? If we're multiplying by 10, we're going to move that decimal point 1 to the right. So we're kind of doing an unexpected flip, but our estimate here is going to be 3. Now we're going to write our multiplication problem, of course, remembering that the longer number should be on top, and also remembering that we do not need to line up our decimal points here. Now we just multiply as usual. 3 times 2 is 6. 3 times 4 is 12, and we bring that 1 around. 3 times 9 is 27, plus 1 is 28. Now, if we're looking at our estimate compared to our exact answer, that tells us this is going to be where we want to place our decimal point for it to be close to 3. But again, we know our rule. 1, 2, 3. 1, 2, 3. Okay? So we're right. Our estimate matches our exact answer. Well, is close to our exact answer. And it helps us with our rule as well. Okay, so we're going to shift gears. We're doing a couple more. You'll notice we're now looking at hundredths, 5th graders. So if we're doing hundredths, what that means is that we're going to be moving that decimal point how many to the left? Yes, 2 places to the left. So let's start with 8G. We're going to work together. So 4/10 times 6/100. So we want to do our estimate here. So this gets a little bit trickier, right, when we're multiplying decimals and decimals, but we can do it, right? If we're thinking about 4/10 times, I guess I would probably go 0 here. We're going to end up close to 0 with our answer, okay? So now we want to write our vertical algorithm. Of course, remember, we want to start with the longer number, which this is our longer number. So we're going to write that on top. And then remembering, we do not need to line our decimal points up when we're doing our multiplication of decimals. Now we can multiply, okay? 6 times 4 is 24. And now we have to figure out where the decimal point's going to go. Okay, this is one where it's going to be, our estimate will get us close, but really this exact answer is going to be what's going to help us, looking at our rule here. So I see 1, 2, 3 decimal places here. So 1, 2, 3. So what does that mean? If we need to have 3 decimal places, what do we need to do? You might be thinking that we need to add zeros, and that is exactly right, 5th graders. So now we can see that these match pretty well. This one's a little bit trickier because of how we did our estimate, but it would be hard to estimate with this one without just finding the exact answer, okay? Okay, let's see. Let's go on to I, 8I. So 2 9/10 times 5/100. So again, our estimate here, I would round this to 3, and then we're going to break this into 5 and 1/100. So 3 times 5 is 15. And if we're multiplying by 1/100, we're going to go 2 to the left, and we get 15/100. So that's our estimate here. So now we're going to stack this vertically. So looking at what we would usually do, I'm telling you to put the longer on top. So 5/100 and then 2 9/10. And remember, we do not want to line up our decimal points. We're multiplying now by a 2-digit number, which is fine. We know how to do this. Our rules stay the same. Okay, so 9 times 5 is 45. When we move over a place value, we need to add a 0, just like we would if we were multiplying whole numbers. We add a 0 to our second row of multiplication. 2 times 5 now is 10, and we add. 5 plus 0 is 5, 4 plus 0 is 4, and then 1. So now we could have some ideas here, right, where the decimal point would go. This estimate would indicate to me that we're going to put it here, right? Because we don't have ones or tens or hundreds. But our rule here, 1, 2, 3, 1, 2, 3, confirms that, right? We see that that rule confirms that we need to be putting our decimal point there. Okay, I'm going to ask you to do, we'll do 2 on your own, but I'll have you do it just one at a time. So why don't you pause and do 8J, then come on back and see how you did. So remember, we're trying to make our estimate as easy and simple as possible. So I would round this to 4, and then I would break this into 4 100ths. 4 times 4 is 16, and if we multiply by 100th, we're going 1, 2 to the left, and we end up with 16/100ths. So now we write this vertically, and again, the longer on top tends to be the most straightforward, okay? So now we do our multiplication. 4 times 9 is 36. When we go to the second row, we have to add that 0, and then we do 3 times 4, which is 12, and add 6, 5, and 1. So as we're comparing our estimate to our exact answer, that indicates our decimal point should go there. But 1, 2, 3, 1, 2, 3. It works. How'd we do, 5th graders? Did that go okay? Hopefully you guys found that it was okay. Okay, I'm going to have you now do 8. Is that an L? Yes, that's an L. 8L. So pause, give it a try, come on back and see how you did. So I would have rounded this, 13 is fine, 12 is fine, 10 maybe also fine, okay? And again, we're going to break this apart into its 2 parts. So now 13 times 3 is something that we can do in our heads, is 39. And multiply by 100th. And we go 1, 2 to the left and end up with 39/100ths as our estimate. So now we're going back and finding that exact answer. Okay, so we're going to stack these, and again, they're the same length, but the decimal points don't line up, and that's fine. We don't need to worry about lining up those decimal points as we are doing our vertical multiplication of decimals. So now we multiply. 3 times 7 is 21. Carry that 2. 3 times 2 is 6, plus 2 is 8. 3 times 1 is 3. So as we're looking at our estimate, that's going to tell us that our decimal point goes here. But again, we check our rule. I see 1, 2, 3 decimal places. 1, 2, 3 decimal places in our answer. Okay? So, 5th graders, as we're moving on, okay, so we're seeing that we've been using our estimates in order to find, to kind of back up our rule, but really moving forward, the rule is what you can apply, okay? So as we're looking at practice work, there will be potentially some estimating in the practice work, but Also, we're kind of going to be shifting towards just applying the rule to find the answer, okay? Homework wise, we're going to be just applying the rule to find the answer. So you're just going to do the multiplication and then you'll get an answer, okay? In addition, there's going to be some of those review problems included as well. So you want to make sure you're doing both parts, right? Both the homework exercise and then also those review problems that are included. Okay, and you're gonna want to be submitting a picture of that work. But again, I'm looking for the work. So if all I see is an answer, I'm gonna return it to you and say I need to see that work because I need to see you showing your thinking as you're doing your multiplication. Okay, so doing that work on any piece of paper and submitting a picture. If you're having questions, right? Remember, if you have questions now, come see me. If you have questions after the practice work, come see me. If you have questions with the homework, come see me and we can talk. Okay? Looking forward to seeing your work, fifth graders.